Hey, it's Ross from rosslukeman.com. Today I'd like to talk to you about how to wire in the VE.Bus BMS from Victron Energy in conjunction with their smart lithium batteries. So this is an external BMS that is going to communicate with the batteries via this external communication cable, and it's going to essentially keep the batteries inside the rails as far as their acceptable voltage range and their acceptable temperature range. So this is in contrast to the BMSs or battery management systems that are built into the top of a lot of batteries. Those are essentially going to have the same guidelines as far as the acceptable voltage range and acceptable temperature range. And if it gets out of range, it's just going to disconnect the battery from the overall system. So what the external BMS is going to do is it's going to take in the data from the battery or multiple batteries that you have daisy chained together, and it's going to make sure that the cells are within their acceptable temperature and voltage range. If they're not, the BMS is actually going to not cut off the battery itself, but it's going to reach out into the broader system, and it's going to shut down the AC and DC loads, and it's going to shut down your chargers such as your alternator charger, solar charger, or shore power charger. Now with this particular BMS, this is the VE.Bus BMS, and it has a RJ45 8-pin plug here to connect to the VE.Bus products from Victron. So their VE.Bus chargers are going to essentially be shore power chargers such as the Multiplus, the Quattro, or the Phoenix charger, and it's going to take grid power and convert that and charge your batteries. And this is going to be able to communicate with those and actually throttle down the current if these batteries get into an over voltage or over temperature situation. It can throttle down those chargers, reduce the current, or if needed, completely turn them off. So it's kind of a more granular, sophisticated battery management system. The flip side of that is that you have to wire it in. So with the built-in BMSs in the batteries, such as the Victron Super Pack with that BMS is built right into the top of the battery, it's ready to go, it's ready to drop into your system, and you can even use it as a lead acid replacement where you pull out your lead acid battery, drop it in there, connect the cables. You may have to dial in your chargers for lithium or possibly change your chargers, but in general you don't have to mess with the rest of the system. So with this one, it's going to be a little bit more sophisticated monitoring and control of your system, but you've actually got to run the wires from this to each charger and to things like your DC loads to shut them down in an adverse event. Now, I would just like to say, as far as the battery management system in general, this is not going to be shutting down your battery in a day in and day out scenario. It's kind of like the guide rails on a highway. Or a mountain highway. You're not necessarily going to hit the guardrails every day, but in case you go outside the line and outside of where you're supposed to go, the guardrail is there to keep you safe and to keep you from flying off the mountain. So the BMS is the same. It's just going to make sure that your battery does not go into a catastrophic event that either causes a fire or ruins the cells inside your battery, making it useless and destroying the investment you've made in your battery. So it's kind of just the guide rails, and you may have seen in some of my other demonstrations, I'll use this battery without a BMS if I just want to turn on a light bulb or give a charge for a few moments. I can use it. The battery is operational without the BMS, but this is the guardrail that's going to protect your investment and make sure things do not go outside of their acceptable ranges for voltage or temperature. So the data that the batteries are going to have, they actually generate their own data, which you can pull up. It's got a, because it's called Smart from Victron, it's got a Bluetooth connection. And if we go into the Victron Connect app, just bring that down here, it's going to pull up the battery, and we can go in there, and it's going to give us some parameters. So you can see the individual cells here. And you can also see if the cells are balanced, which you can kind of tell yourself. If the numbers are off, then they're out of balance. It hasn't been charged in over a month, so it goes into the unknown category. And as far as the last full charge, it also is unknown. It's going to give you the battery temperature and the overall battery voltage, and then here at the top it says ready for use. So when the battery is too hot or too cold or too high or too low on the voltage, that at the top, instead of ready for use, it's going to say cannot charge, cannot discharge, out of range, something like that. So it's going to tell you essentially the status of the battery. So the data you get here on the Victron Connect app is being generated inside the battery. So it does have a little microcontroller in there where it is generating and storing its own data. And that same data is what's going to be sent through these lines to the VE.Bus BMS. So you can see the data, and that is one of the things with this system. It's a little bit harder to install, but you're going to be able to look inside each battery and see each individual cell and see the temperature of each individual battery. And if that sounds good to you, then this may be a system that you want to install. Now, in contrast to that, if you feel like this video is too involved and too difficult, then you may be a candidate for the built-in BMSs where you have you just drop them in and they are going to disconnect from the greater system in an adverse event, over voltage, under voltage, or get out of their acceptable temperature range. So that would be like the Victron Super Pack, Battleborn, Trojan Trillium. Those are going to be easier to install, but it's a little bit less sophisticated as far as how it protects the battery. They're going to just disconnect from the chargers. The chargers are going to just keep going, whereas with this system, it's actually going to reach out and shut down the chargers, shut down the loads. So it's a little bit more sophisticated in how it protects your batteries. Now, as far as the Victron Smart batteries, I just want to mention you've got a few things going on here. You can connect up to 5 of these in parallel, and you're just going to daisy chain the battery communication cables to each other. And then I've got kind of a home run cable that's going to come back and connect to the BMS. So you can connect up to 5 in parallel. Now you can also connect these in series if you want to go with not only a basic 12 volt system, but if you want to do a 24 volt system or a 48 volt system, you can boost these up in voltage to create a higher voltage battery bank, and the BMS is going to have no problem with that. That is different with the Victron Super Pack. It basically has to operate at whatever voltage that battery is set at. So if you buy a 12 volt battery, you cannot connect those in series and create a higher voltage battery bank. But with the Victron Smart batteries, you can, it's more of a DIY or designer friendly battery in that you can design systems where you connect the batteries in series or in parallel to create whatever setup that you want. And also, we'll also say over the last couple of years, they've shrunken these batteries. This one is from 2018, but this particular battery is about half this size now. So this is a 160 amp hour. If you buy this battery today, it's going to be 12 inches long by 6 inches deep by 9 inches high. So you can see that's about half the volume. You can get that in the 160 amp hour capacity or the 200 amp hour capacity in the same size case. And then as far as the latest battery, they also have a 330 amp hour that takes up about the same volume as this 160 from a few years ago. So the 330 amp hour is a little bit shorter and a little bit longer, but it is about the same volume as this 160. So they've kind of cut their battery size in half. And what that has meant is if you look at this system from 2019, this is 3 of their new 200 amp hour batteries. This system is 600 amp hours, and you can see based on any other battery brand, this would take up the space of 300 amp hours. So you're able to get double the capacity in the same amount of space with these batteries. So that helps if you have a very small compartment where you're trying to add your batteries, or you want to be able to add twice the capacity in a given battery compartment, and you need a high capacity system and you need it to be as dense as possible. These batteries for their capacity are super small compared to a lot of the other lithium batteries out there. And I'll say that's on top of the weight and size savings that lithium has over lead acid already. So lithium's already ahead of the game. The Victron Smart lithium batteries are even smaller. The energy density of these is pretty crazy. So that's a few points on these batteries and how the BMS works with them. At this point, let's zoom in and I'm going to show you what comes in the box with the VE.Bus BMS. And then in the last part of this video, we're going to wire it in and I'm going to show you how it connects to an overall power system with the battery and all of our various chargers and loads. But before we zoom in, if you're interested in your overall van or RV electrical system, I've got a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of not only batteries, but the 3 major charging sources that you're going to find in a van or RV, which are solar power, shore power, and alternator power. And it's going to talk about how they all have strengths, but they also have weaknesses. But when you combine them into a holistic power strategy, it's going to make sure that you have a good charge no matter where you go out on the road, whether you're plugged in at a campground or you're boondocking way out in the desert. You're going to have a good charge source, so you're not going to have to worry about running out of power and you can just enjoy your trip out there. Now, on the second part of the cheat sheet, there is a discussion of different battery chemistries, and that's going to help you narrow in on which battery type is going to be right for your situation. And then lastly, there is a really neat conceptual diagram that's going to show essentially your overall power system on one page, and it's going to show your charging sources there at the top and how they connect through the system. What are those connections to get that power through the system to charge your batteries and then come out at your end devices such as your phone charger or your microwave. And it's also going to show how the different charging sources kind of play nice together and don't mess up each other. So how does the solar power not mess up the alternator charger, and how does that not mess up the shore power charger? How do they all work together to charge your battery bank and get distributed throughout the rest of your system? So I think you'll enjoy that diagram. If you want your own copy of the Ultimate Van Power Cheat Sheet, all you have to do is click the link below or go to rosslukman.com/vanpower. So with that, let's zoom in here and take a look at what comes in the box with the VE.Bus BMS. So as far as what comes in the box, we have the VE.Bus BMS itself, and then we're going to have a short UTP cable. This is basically an Ethernet cable. And then we're going to have the VE.Bus BMS mains detector. Let me explain this little device. So basically, in a low battery shutdown scenario, the VE.Bus BMS is going to shut down the inverter charger because it can be a load. That inverter is going to be supplying power to your appliances. So in a low battery situation, it's going to shut that device down. The problem is that device is where the shore power comes in. So let's say that you have a low battery shutdown and then you drive your van or RV over and you plug in. This has no way of knowing, because that inverter charger is off, it doesn't know that shore power is available now. So this little device is going to tell this one, hey, we've got shore power now. Go ahead and turn on the inverter charger and it can use its shore power to recharge our batteries. So that's what the VE.Bus BMS is for. And you can see you've got a couple of wires here. This is for neutral and the hot line. And I did have 2 wires. You can see that I clipped one of them off. Some of the inverter chargers, like the Quattro, they have 2 incoming shore power lines. So one of them would be to the power grid and the other one would be coming from like a generator. So it can accept up to 2 lines. And so the mains detector will come with 2 separate lines to detect those 2 separate shore power sources, essentially. So I cut off the one line because I did not need that, but when you get a new one, it's going to come with 2 separate lines. So let's go ahead and move that out of the way. As far as the connections on the VE.Bus BMS, let's take a look. First off, at the top, we have the Multiplus Quattro plug here. So that's going to go out to the inverter charger. And then we have one that's called remote panel. So a remote panel would be like this multi-control GX. Now, typically the multi-control GX would directly control, it would directly connect via its RJ45 port there on the back. It would connect over to the inverter charger and turn it on and off and control it directly. But with the BMS system, in the system, this is going to act like the middleman. So this particular remote will plug into the BMS, and then the BMS will actually plug into the inverter charger. And the reason this is the middleman is if you have an adverse event where the system is shut down and let's say you don't know and you come in and try to turn on your inverter in the morning, you want to make breakfast, this device can actually stop the signal. You can say, hey, let's turn on the inverter, and this BMS can say, no, sorry, we have a low battery shutdown. I've turned off the inverter. I'm not going to send your signal on to the inverter to turn it on. So it can actually stop signals and override your signals if needed. So that's how that works. In the bottom, we have these two silver inputs. That's where the battery communication cables are going to come in. Again, you can link up to 5 batteries together and just home run them. And so all that battery cell and temperature data will come in here, and the BMS will be able to process it. Now, as far as these 4 ports here, right off the bat, I do want to mention this particular BMS is a few years old. They have added a 5th port called pre-alarm here, which is basically going to set off an alarm if you have a low battery situation. It's going to go off before the BMS shuts down the system. You can also do that with a battery monitor, which I recommend that you have a battery monitor in your system. So you don't necessarily have to set off alarms from the BMS itself. You can set it off from the battery monitor. Now, these 4 inputs are also on the new BMS. So we have battery plus and minus. We can send 9 to 70 volts DC here. So I have a 12 volt battery system, so I will be sending 12 volts into these inputs. And the inputs in the middle are load disconnect and charge disconnect. And essentially what it's going to do is it's going to take your, in our case, 12 volts, and it's going to send those out as a control voltage to your chargers and your loads. And we can have multiple chargers and multiple loads lines going out here. But in our case, it's going to send 12 volts out to those as a control voltage, and it's going to turn those on. And what it's going to do, if it needs to turn off the loads or it needs to turn off the chargers, it's basically going to remove that 12 volts and drop it close to 0. And that will tell that charger or load to shut off. And that's what it's going to do in an adverse event. So with the loads in a low battery situation, it's going to remove the 12 volts from the loads and something like a battery protect, and it's going to cut off all of your loads. So that could cut off your entire 12 volt DC fuse block, something like that, by removing the 12 volt signal voltage from that battery protect. And you'll see that here in just a bit. And then on the charge disconnect, that could control a Victron Orion charger for your alternator charging, something like that. It'll remove that 12 volts and shut down that charger as well. So that's how it's going to control the various chargers. At this point, let's go ahead and wire it in, and I'll show you how it works in real life. We've got the VE.Bus BMS installed here in an overall system. I know there's a lot going on here. I did want to install several types of chargers and several types of loads so that we could look at the different ways that the BMS is going to control the greater system. So we've got a variety of control devices here controlling our different chargers and loads, and we'll go over them one by one, and hopefully this will make a little bit more sense as we go through it. First off, I want to mention that the battery is connected via its battery communication cables to the bottom of the BMS, and that essentially makes the battery the boss. So it's going to tell the BMS what it wants. Chargers, turn off the chargers, turn off the loads, and it's going to control the system. So let's just go through the cables connected here. First off, we have our blue UTP cable, and that's going to control the Multiplus. So that's going to be our shore power, and it's also going to put out, with the orange plug there, it's going to put out our AC power to our wall outlets and appliances. You can see the blue cord runs through the BMS mains detector, and as I mentioned earlier, in case there's a shutdown of the chargers, the Multiplus gets shut down by the BMS, and let's say we go and plug into shore power, this little device is going to wake up it's going to tell the BMS to wake up the Multiplus after a shutdown. So as mentioned earlier, that's how that connects. And the little short cable that came with the BMS, that's going to be the link between the mains detector and the bottom of the Multiplus. It's going to plug into the VE.Bus port there in the bottom of that unit. So that is how our shore power works. Next up, we have alternator power. Here we have a Victron Orion smart charger. And this is going to have a couple of lines that would come from the front of the vehicle. So we have a 6-gauge red cable that would be connected to the engine battery. And then we're going to have a ignition wire that would connect somewhere typically around the driver's seat to tell the charger if the vehicle is on. You don't have to have an ignition wire, but that's how I like to wire it. And that actually leads us to the Solid Switch 104, which is the new product. So basically, if you have an ignition wire controlling this alternator charger, typically that wire would come straight in to the bottom of the charger, and the charger would just turn on and off with the ignition. But because we have the BMS here, it wants to be able to override that ignition signal. If it doesn't want that charger on, it can basically break the line so the ignition signal never gets to the charger. And that's where the Solid Switch 104 is going to come in. You can see these little yellow lines on all of these. They are originating at the BMS. And basically, like right now, this switch is off. Let's say I'm going to hook up the ignition wire. So if we put 12 volt positive on this orange ignition wire, we're going to pretend the vehicle is on. You can see the little switch turns on. But if we remove the voltage from that yellow wire, it is going to, let me disconnect the battery. It'll simulate a system shutdown. You can see the switch has gone off now, and the yellow wire has dropped to 0 volts. So that is how the BMS, using that yellow wire, can open that switch and break the ignition line before it gets to the charger. So we'll reconnect our battery. You can see the light is on, everything's all good. And I'm going to go ahead and disconnect our ignition wire and move on to the next charger. So for the solar charger and the DC loads, we're going to use these battery protects. And I have to say, this battery protect is way too big for what we need here. I had a 220 amp laying around. Typically I would use these smaller 65 amp for the DC loads and the solar charger. This is not needed, but I had to use what I had. The solar connection, you can see the solar wires coming in. They would be coming in from the roof, come into the solar charge controller, and battery positive and negative are here. Negative goes down to here, and the positive goes down to our positive bus. And this is just going to break the line. So right now everything is good in the system, and the battery positive is able to flow through here and connect to the battery itself. And what would happen if the unit wants to shut off those chargers, it would shut both of these off with the charge disconnect line. So right now the charge disconnect line here is split into 2 lines. It comes out as one, goes into a butt splice, splits into 2 lines, and goes here and here. In a charger shutdown scenario where the BMS wants to shut those down, it will drop the voltage from 12 volts in the yellow line down to 0, and that would essentially pull power from this yellow line, and it would break the solar positive line here, the battery positive line coming from solar, and it would prevent any solar power from getting through to the battery if the battery's in an over voltage or over temperature scenario, or for whatever reason just wants to shut down all charging. That's how it would do it. Now there is another way to shut down with the solar chargers. There is a VE direct port here, and you can get a VE direct non-inverting on-off cable from Victron, and it will connect basically directly from the charge disconnect straight into the bottom of the solar charger. I did not want to use up that port because I would typically hardwire the charger from the VE direct port over to a Servo GX or Color Control GX so I can get a system overview on one screen. So I wanted to leave that port open, and this battery protect is the alternate way that you would shut down solar if you need to shut down the solar charger with this BMS. So that's the solar, and then on the DC, 12 volt DC side, we're going to use a battery protect to break that positive line as it goes into our fuse block. So I've got this little light here, and you can see that it's on. In a low battery scenario, the BMS would say, you know, the battery voltage is too low, we need to shut down our loads. It would remove the 12 volts from this yellow line, and we can simulate that by just pulling the line here, and it's going to break that positive line and shut down all your 12 volt loads. And then let's say you plug in, or a charge source becomes available, maybe you start the engine, the battery voltage rises back up, and the BMS is going to turn the loads back on. So it would apply 12 volts again and allow the power to come through and power your 12 volt loads. So these are kind of three different ways. Actually, these two would be the same, but 65 amp or 220 amp battery protect to break the line for the DC loads or the solar, and then the solid switch 104 to interrupt that ignition wire for the alternator charging. So we've got multiple ways that the BMS is controlling things. And again, let's jump over to the Multiplus and talk about that. You're going to need to do a little bit of programming to get the Multiplus to work with the VE.Bus BMS. So you'll use the VE configure software on a PC computer, and you're going to use the MK3 to USB converter to essentially use the VE.Bus cord there. You're going to plug that into the converter, and the converter plugs into the USB port on your laptop. And I'm going to mention a couple of settings. I'm not going to mention all the settings because it's kind of beyond the scope of this video, but you want to select the battery preset of the Lithium smart battery preset in the VE configure software, and it's going to populate the correct charging voltages and absorption time for this type of battery. And then on the assistance tab, the assistants are basically little apps that you can run on top of the basic software inside the Multiplus. So the assistant that you want to add is the VE.Bus BMS assistant, and that is going to tell the Multiplus that there is a BMS, VE.Bus BMS in the system, and this is basically the boss, and it needs to run all of its operations through this device. So again, the VE configure software, it is a little bit more involved, but let me go ahead and turn off this light. I have to say, it did take me a couple of days to set this up. I did stitch my video together, so it looks like I just rolled right into this. But it took me a little while to set this up. I used a lot of double-sided tape to kind of get the layout, and then I wired each device one by one. But it's more work, but it is pretty sophisticated. I have to say, on the battery last night, it was unbalanced, and I plugged in the Multiplus to the shore power to the wall outlet over there, and the battery did a really interesting thing. As it balanced out, the internal cells were out of balance because I haven't charged it in over a month, and it would turn on the Multiplus and charge for a few minutes, and then it would turn the charger off and the cells would balance. I was watching it on the phone app, and the cells would balance each other out. The one that had a high voltage would kind of bleed off, and the other cells would come up. And then about 20 minutes later, it would turn on the charger again, and it basically repeated this process probably about 10 times. And sometime around midnight, I had gone to bed. It fully balanced the internal cells and reached a full charge. So I was impressed with how the battery used the BMS to turn on and off the greater system to balance itself. So it is quite a sophisticated system, and it is a little bit next level as far as programming the Multiplus and putting in all these little yellow wires. It's going to take a little extra work, but it's a pretty impressive little system. So I hope that was helpful. Again, if you want help with your shore power, alternator power, and solar power, as well as the batteries themselves, you want to grab a copy of the Ultimate Van Power Cheat Sheet. To get your copy, just click the link below or go to rosslukeman.com/vanpower. So thanks for watching, and I'll see you in the next video.